Alright, this is going to be a tutorial on how to perform a man-in-the-middle attack using ARP poisoning. Just a note before we go ahead and do this is that if your network's under heavy load and you're ARP spoofing the entire network, this can cause the network to crash and make the internet unaccessible for all the users on the network. So just to let you know that before you go ahead and play with it, depending on where you plan to try this out. So ARP for us is a layer 2. It runs on layer 2, the data link. ARP stands for Address Resolution Protocol. So when you're trying to ping an address on your local network, for example 192.168.1.100, as you can see here on PC0, what your computer has to do is turn that IP address and have a MAC address that goes with it. So this involves using the ARP to resolve the address, so hence the name Address Resolution Protocol. The computer stores the information about the IP address and associated MAC address in an ARP table. So from there, when you try to send a packet to another computer or an IP address, the computer will first look up into the ARP table to see if the address is already known with the MAC address. If the MAC address is known for that IP, no ARP will be used, so you can just send and receive. So to sum it up, your computer, it uses a physical MAC address for a direct delivery of a frame to another node, aka a computer within the same broadcast domain. So, but if the IP address is not found, or the MAC address for it, in the ARP table, then we'll send out a broadcast packet to the network using an ARP protocol to ask for who has, 192.168.1.100. In a broadcast packet, the MAC address is changed to all Fs, which is a broadcast. If you know anything about network, all broadcast packets have a MAC address of FF, 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 and so on, which will cause all the computers in that broadcast domain, or all the computers in that local network, to receive it. So if this guy sends it out, it's going to come down to PC1, PC0, PC1, PC2, and then whatever computer has the address that PC3 is looking for is going to respond up to the switch and then back down to PC3. So like what I was just showing you, so only that computer with that requested IP address will respond with an ARP packet that includes the MAC address, which it can receive packets for that IP address. So all other computers will drop the packet as it's not for them. So how spoofing goes into play here is because ARP doesn't provide a method for authenticating ARP replies on a network. ARP replies can come from a system other than the one with the required layer 2 address. So in ARP spoofing, the answering system or the spoofer replies to the request for another system's address with the intent on intercepting the data bound for that system. So for example, the router. So if PC3 is trying to send information out to the router, then the spoofer will say, hey, I'm the router, and then from there it will get sent to that computer, or the attacker's computer, then from there transferred out to the router, and then back to the internet. And then we also tell the router that we are PC3, so when it's coming back through from the internet, it hits the router, it will get then sent to the attacker first, which is then forwarded to PC3. So this can be used, like I was just showing you, for man-in-the-middle attacks or denial of service attacks for users on that network. So let me go ahead and give you a brief visual demonstration kind of thing. Here, I'll push this to the side. So as you can see here, I'll go into PC3, and we're going to try to ping PC0, so 192.168.1.100. But as you can see here, we've checked the ARP table, and we have no ARP entries found. So when I go ping, 192.168.1.100, you can see the dark packet, as up here, is the ICMP, and the green packet is the ARP packet. So the ARP gets sent out to the switch, so the layer 2 device, which then gets broadcasted. As you can see, every computer on that broadcast domain gets the packet. As you can see, it's not for PC1 or PC2, so the packets are getting dropped. But PC0 responds saying, hey, that's me. And then it sends it back to PC3. So then now your ping request can go straight to the switch and forwarded right to PC0 and back. And then there's, and then you have a successful ping. And as you can see here, we can stop this and we can go arp-a, and you can see here we have the MAC address for the IP of 192.168.1.100, which is PC0. So we'll no longer have to ARP for this. So us as an attacker, we can put our little attacking machine here. Say, you watched a couple of my other videos and we've cracked the wireless password and we've connected, and now we're part of the network. So when PC3 tries to go out to the router and out to the internet and then come back, to send and receive information to view websites, well, what we're doing is that we're telling PC3 that we are now the router, and then we're telling the router that we are now PC3. So what used to be, what used to be a normal communication from PC3 to the router, and then from the router out to the internet, and from the internet back, and then back to PC3, is now going to go a little something like this. PC3 thinks we're the router, so we're sending out to our attacker machine, which then we're going to forward to the router, which is going to then send it out to the internet. So when we get a response back from the server or the web server, it's going to come back to the router, which is then going to send it back to our attacking machine, which then we can forward back to PC3. In the meantime, we can view all the data that is going through our computer, we can alter it, and we can do tons of stuff. So I'll show you that in the next step. Alright, so I'm going to do this demonstration in VMware Workstation. For those of you that don't know what it is, it's a virtual machine environment. So on my laptop I can install multiple operating systems. So I can have Windows 7 running again. I have Metasploitable 2 running here, which is another Linux machine without a graphic user interface. And then I have Linux again, which is going to be our attacking machine. So these are pretty much set up as individual computers, just all in one main computer kind of thing. So we'll go ahead and we'll get started configuring our system for the attack. Now that Windows 7 machine that I did show you over here, this is going to be our victim that we're going to be viewing the data that they're transferring and other things. So the first thing that we can do is we'll find out what our gateway is, so the router. We can do that with a command called route. And as you can see here, our gateway is 192.168.36.2. Now that we've connected to the network, in many ways, we could have watched one of my other hacking videos and cracked the wireless password and connected, or you're just at a buddy's house or workplace or whatever. If you're at a workplace, I would want to get permission before you play around with something like this, as you can cause network instabilities, like I was warning you about before, users not being able to access the internet and so on. So now that we've connected, we can go ifconfig, and this is the IP address that we have from DHCP from our router. The mask, so we know it's a /24 for the subnet. So we can go ahead and view what devices are connected. It could be cell phones, tablets, computers, anything that's connecting and using the network and the internet. So we can do this with a command from nmap. We can do what is called a ping sweep. So with the /s and a capital P, and we'll put in our network 192.168.36.0 and then /24. So this is going to go ahead and do a ping sweep for all 255 hosts that are in this subnet. As you can see, we have 5 devices that are connected. Now, from viewing what our gateway was, we know that this is the router kind of deal. And then these are other computers or devices that are connected. Now we can do one more command from nmap to try to figure out what the operating system is with a --O. And then we'll go ahead and we'll scan again. And this is likely going to tell us if it's an Android phone, a Windows phone, if it's a Linksys router, or if it's a Windows 7 or a Linux machine, and whatnot. So, as you can see here, it's completed. We can scroll up to the top. We can see the IP, and then we can see some ports that are opened. Although I didn't really select for a full-out port scan. We can do a video on that later. Our router, which is it's saying that it's guessing Windows 7. It's a 93% guess, but we can see here that we have DDWRT over here, which is a router software, and then this is our this is our Windows machine, our Windows 7 machine's IP address. As you can see, running Microsoft Windows 7 or Vista or 2008, so it's running Windows 7. Now we can go ahead and we can verify the IP address on the victim machine. I'll just make this bigger with an IP config. And as you can see here, it's 192.168.36.30 or 136, and then our default gateway, which is the .2 again. So from here, we have to go ahead and configure our operating system for the attack. What we're first going to do is set up port forwarding so we can forward the data from our victim machine. We can do that with the command echo 1, and we want to put this into proc sys net IPv4 and then IP_forward. Now, this was a 0 before, so what we can do is we can go ahead and we can cat this file so we can view it and make sure the 0 has changed to a 1, as it has. So the next step is we're going to configure Iptables, which is the Linux firewall settings. I'm not going to go into great depth on Iptables or anything like that. It can be a big subject. If you want to know more about Iptables, you can go ahead and do a quick Google search on that. So Iptables -t nat a, and then we want to do pre-routing, and then -p for TCP, and then our destination port 80, which we want to redirect to port 8080. A little mistake in here. I forgot the S on Iptables. Okay, so we've done that. And now we can go ahead and we can do the ARP spoofing. So I'm just going to open up 2 more windows, which are just going to be smaller. What we're going to have to do is we're going to run ARP spoof. And as you can see here in the options, we need to use the -I for the interface, and then we're going to use -T for target. So it's going to go the target that we want to use. So in our case it's the Windows 7 IP address, and then the gateway, which is the router's IP address. So ARP spoof, we're going to go -I, and in this case, if you don't know what interface you're using, we can run an ifconfig, and since I'm doing a wired connection, mine's Etho. If you're connected by wireless, you're more likely WLAN 0 or something like that. So we can do that, Etho, and then T for our target, so which was 192.168.36.136, and we can check that just to make sure. Yes, -136. And then our gateway, which if you remember was .2. We'll put 192.168.36.2. And then over here, we're just going to do the opposite. ARP spoof. And then we're going to do -I again, our interface. And then we're going to do the router first, and then our target. And I forgot the -T. So we'll go hit enter on that, and then we'll start running this one too. Now, this is doing exactly what I was telling you before, telling the Windows 7 computer that, hey, we're your router, and we're telling the router that, hey, we're the Windows 7 machine, and then we're just forwarding the traffic as necessary from there. So we can go ahead and we can minimize these, and I'm going to show you a few programs that we can run and a few things that we can do while the man-in-the-middle attack is taking place. So we can, one of the things we can do is we can strip the SSL security that's in browsers for when you log in. If you ever notice when you go to Google email or AOL or whatever you use, Facebook, banking sites, if you look in the URL, you're going to notice that the HTTP is actually HTTPS for the SSL. We're going to strip that off back to HTTP so we can see what the user enters for username and password in clear text. I don't know why that pops up. So we can go, we can use the program SSLStrip help, and the option we're going to use is -K. This will work if the victim machine has any open connections to Facebook or whatnot. It's going to try to kill them so that they have to relog in, kind of deal, and then we can get the credentials from there. L, the default port is looks like 10,000, but as you know from when we did the Iptables, we redirected port 80 to 8080, so we're going to have to specify 8080. We're going to use the -W, and we're going to write the file to our desktop, our SSLStrip log, and then we're going to view that file in real time. So we can go ahead, SSLStrip -K -L, and we're going to change that to 8080 -W. I'm going to store this file on my desktop. I'm going to call it SSLStrip log.log, and I'm going to go ahead and I'm going to run that. So now that SSLStrip is running, let's go over to the victim computer here. We'll open up Internet Explorer, and we'll navigate to Facebook. Okay, so it's working. Let's go to Facebook again. There we go. As you've noticed here, like I was saying before, there is no S on the for encryption for the login. One of the things I forgot to do is I'm going to run tail-f on our file, that's on our desktop. And what the -f does is it's going to display whatever gets dumped into this log file in real time, so we don't have to constantly cat the file to view it and whatnot. So I'll just expand this maybe for easier viewing. And then let's log in. So this is a fake email at whatever.com, and then my password is going to be not underscore real password, and I'm going to go log in. No. So it's not a real account, obviously, so it doesn't let us log in, but the point is to gain the username's password. So as you can see here, it's a little bit of a mess. You have to do a little bit of searching, but you can see email. The email that was used to log in is a fake email. And then we have a password, not a real password. As you can see, we've successfully got the credentials for that website. So let's go back to, let's say, google.ca. And let's see if we can sign in. So it's not letting us. Okay, as you can notice again, the S is off. So I can do my email at google.com or google.ca, and then fake password. Sign in. Yet again, not an actual account, so we're not going to be able to sign in. But as you can see here, we can search through this again. I'll spread this open a little more. We got a little more garbage in here. So my email at google.ca, and then password is fake ass password is right here. So that's one thing that we can do, is we can steal credentials from people that are logging in and so on. So we'll leave that running. Another program we can use is called driftnet. What driftnet is going to allow us to do is it's going to allow us to capture images and pictures that are on the victim's browser as he's browsing the internet. So we can kind of get an idea of what he's looking at. You might get screen caps of emails that you'll be able to read through pictures kind of thing, or other things. So let's go ahead and we'll take a look at the driftnet program. So as you can see here, we have a few options. The -h, like most programs, or --h or --help, is going to show you the help file or the help menu, with options for that program. As you can see here, we can do verbose, which is just going to show us a little bit more information than what's currently on the screen. -b to get it to beep when a new image is captured. I've tried this, and I do not get the beep or any sort of sound when an image is captured, so if you get it to work, awesome. And obviously our interface, which is what the data is traveling on. If it's wireless or wired, you have to pick accordingly. We can set the card to listen in promiscuous mode or not. We can set the amount of pictures to be captured and so on. I'll let you read the rest of it and play around with the program yourself so you can learn a little bit of something. So we'll go ahead and we'll run it. Driftnet -b. I'm going to try for the sounds. I'm recording through a headset, so I don't even know if it will play back into the recording or not. -i for our interface, and then we're going to let it run and enter to run it, and you're going to notice there's this little box that appears. I'll stretch it out. Come on. That's black and empty. What this is where the pictures are going to be stored. So go ahead, we'll hop back over to our victim's computer, and let's search for Lambos, I guess. We can view some images. You know, nice car, whatnot. You know, only 193,000. It doesn't seem like much, eh? And so on. So if we jump back to the attacker's machine, you can see here it's captured a few images off the computer. So as we do more browsing, you know, we're just looking through, it should capture more of them. Cisco, we can do network topologies. We can view a few of these. Awesome. Alright, and then so what we'll do is we'll go back to the attacker's machine again and see if it's loaded up anything else. So as you can see in the images on Google, it's loaded a bunch of network topologies that we're viewing. So that's one other thing that we can do. Another program we can use is called urlsnarf. So urlsnarf, as you can see, the options here are for the interface, which is ETH0. We can go ahead and run that, and as we redirected to port 8080, it's now listening. And we can go back to the victim computer and we can start browsing. Now what this is going to do is it's going to report back to the attacker the websites you're going to. So if I were to go to Facebook, for instance, we can come back here. Let's make this bigger. And as you can see, it says Facebook right here. Now we can go to google.ca and we should have captured that also. So google.ca. We can also go here, right click, open link, and we can see what they see. So let's try to make it a little bit better here. Let's go back to that Lambo and see. So if we go to lambo.com, we can put in that ULR, our Lamborghini. They're viewing that. We can come back here. We can view the stuff. And as you can see here, we have a Lamborghini.com. We can open that up. And yet again, we're seeing exactly what they're seeing. Now, another thing I like to do is if you want to keep this information for later, instead of having it all up on the screen, is we can direct it into a file. Somewhat like we did, pretty much the same thing what we did to SSLStrip, except we don't use the -w. Desktop, and we're going to call it ULR snarf log.log. I'm going to go hit enter, and let's do a little browsing again. So we can go, we'll reload this page, we'll go back to facebook.com, we'll go back to google.ca, and we'll throw in a Twitter. I might want to put www. There you go, twitter.com, not .ca. Come on. Oh, Stack Overflow. That's never good. Alright, let's close this browser. We'll reopen it. See if we can go to Twitter now. Twitter.com. Looks like we're having a couple browser problems here. But in this case, we can stop this. We'll make this window a little smaller. And as you can see here, we have the file where we stored the ULRs. So we can clear up this screen. We can we'll move ourselves up to the desktop, and we can cut the file and view it. So we can now we can go through. It still has the links if we want to right click and open. What we can do here, since we've done that, we can cut the delimiter, and we can cut for field 1, 2, 3, 4, 5. I think I go field 6. Nope, field 7. And it gives us a little cleaner look of twitter.com that we visited, Facebook, Google. It just cleans it up from that mess we had. We're just pretty much cutting out all the rest of the garbage and searching for just the ULR. So then we can search through here. We can go, oh, okay, what were they viewing right here. We can open the link, and sometimes it will have nothing. Maybe it's loading stuff. But let's see if we can go to the Twitter. Okay, well, some of these are CSS, which is website stuff there to organize how it looks. So we can go to Facebook. We'll open up the link, and it's going to take us to the Facebook thing, somewhat to where they were. So, alright, there's just a few things that we can do with a man-in-the-middle attack done with ARP spoofing. When you stop these, I should actually do this real quick to show you that, as you can see here, we go ARP A, and if you see the MAC address for the router is the same as the MAC address for our attacking machine. Now we can come back here to the attacker's machine, and actually I'll just open up another browser or terminal. You can do if config, and you can see our MAC address here ends with 25E9, 25E or 9E, and when we stop the attack, it's going to we're going to be updating the ARP tables back to where it should be. We're going to, as it says, cleaning up and re-ARPing tables. So it should set the proper values, the proper MAC addresses for the IPs for the regular computer. So if we want to go ahead and we can ping, I think it was 103 or something or whatever. What was the attacking machine address? If config 137, and stuff like that. And same thing with the gateway. We can still now access these just as if normal. And if we do an ARP A, you can see now that the MAC address for the gateway is actually the actual MAC address of that gateway or router, and then the MAC address for my my attacking machine is still the same, but the MAC address has been put back for the IP address of the router. Anyways, there's a few things you can do. There's a whole bunch of fun stuff you can do. You can flip the victim's browser upside down, or flip or reverse it. You can add text and images to their browser and stuff like that. And like I said, you can do a denial of service. We can stop all their traffic from going anywhere, and any traffic trying to come back to them. These are other things that you can look into on Google. I may do a fun little bit of a tutorial on it later. There's another program called I think it's EaterCap that I'll be doing a tutorial on later, and part 2, and then I'll be doing how to do man-in-the-middle attacks in Windows as a part 3. Alright, well, thanks for watching. Hope you enjoyed the video.